Hi, this is Francis Sideco with TIRIAS Research. I'm here with Jon Cory from AMD at CES 2024. We're seeing a lot of their great automotive technologies that they're bringing to bear this year. John's going to show us a little bit about their automated parking capabilities.
Yeah, absolutely. Thanks, Francis. So what we're looking at here today is we've been working on some automated parking demonstration proof of concept. We're using actually a real Lexus vehicle, which we've outfitted with a Kriya device. So it's using an ECU that we developed using the Kriya, which is a Sync UltraScale Plus type of device family. It receives 4 fisheye cameras that are mounted around the Lexus vehicle, which are these connectors coming in here over GMSL2. And it does vehicle control over this CAN interface here. And so we've implemented this on the Kriya. We're using an AutoWare open source software stack that we've adapted to our technology and our use case. And so we can do basically parking assist, forward, reverse parking assist, which you're seeing in the video happening there. Now for this demo, since we couldn't bring the actual Lexus vehicle here to Vegas, we've tried to implement this using a true hardware in the loop simulation. So we have a Cognata simulator running here, which is generating the same distorted 4 fisheye cameras. They're fed through the Xylon Logi recorder. This takes those cameras over 10 gig Ethernet, converts them to GMSL2 interfaces, which are then fed into the same ECU using the same software that we're running in the vehicle. Right, so we're using the programmable logic to do the perception. It detects the parking spaces around the vehicle, and we use the AutoWare stack to actually control the vehicle and park it. And so we're doing the same thing now in the hardware in the loop setup with the Kriya and the Cognata simulator. These are fed into here, and then over here you're seeing stitched video, which comes out of the Kriya. So this is an HMI that we worked on running on our Mali GPU integrated into the device. And so it's detecting parking spaces in the simulated video. Ideally you can control the forward reverse parking using that approach.
How defined does the parking space need to be in order for the system to work? I mean, some of these parking spaces, especially here, they're not very defined.
That's right.
Or if they might not even have lines at all. So, what are the limitations of kind of what it can see versus what it can't?
It's reasonably good with parking spaces, and this is all based on the perception, right? This is all based on an AI algorithm that's been trained on parking spaces. So the neat thing is that we can swap that in and out. So we have programmable logic. We actually have DPUs that we can implement in our programmable logic that we could run different AI models to do that. We're using a partner model here to detect parking spaces. It does a reasonable job. The lines can actually be fairly faint to pick them up, but you do need some sort of line, right, to be able to detect the parking spaces.
Cool. Yeah. So just out of curiosity, what's the game controller for?
Right. So, so the idea was we didn't quite have this ready in time for CES, but we can actually drive the vehicle with the game controller through the Kriya. So the Kriya has USB, and this converts USB messages into CAN. Okay. And the CAN is used through the Logi recorder over Ethernet, fed to the simulator. We can control the vehicle using the game controller. Okay. So it's just another avenue for us to position things.
Perfect. Yeah. Let me just get a little shot of your
yeah, please go ahead.
Display there. Perfect. Well, thanks, John. Appreciate it.
Thank you.
Yeah, looking good.
Appreciate it.